So great to be here. And in this talk, I will present some trends and challenges in human-centric robotics. And I will focus on robot learning side and also a bit human intention reading part. So let's get started. So what do we envision for future robotics? Maybe most of us imagine robots who help us in various tasks, and also they are expected to enter our daily lives. And I envision that robots can learn various tasks by a unified learning mechanism. And that same learning mechanism can be scalable to the human-robot interaction and human assistance. So in order to achieve such a human-centric assist robot, I take the paradigm of imitation learning from the humans. We can teach robots by physical guidance or imitating humans or haptic devices. And teaching robots by imitating humans have multiple benefits. It can democratize robot programming. It can support expressive robot motions and also support efficient skill learning and interactive, more natural interactive behaviors for human-robot interaction. And on top of that, it might have the more good potential to be scalable across any robot. Imitation learning has been applied to various tasks. You see here, the robot is hitting a ball to hit another target, or dancing, or preparing some drinks or coffees. We show some level of generalization capability to a new, slightly new scenarios. And also it can show some capability of learning some long horizon task and motion plannings as well. And recently, we start to tackle more embodied intelligence. We try to tackle more contact-rich manipulations, like assembly, or peeling cucumbers, or here showing also box grasping. They require high precision and also delicate force impedance control. In NIST board assembly tasks, robot has to insert a tiny object which are less than 1 centimeters. And in box grasping, robot has to exert high forces to compress the internal springs inside and not to push the sliding lockers, and also make sure to lock the box locker on the bottom for a firm grasp. So how about the physical human-robot interaction? Can we teach physical human-robot interaction tasks? In some sense, we show some of kind of that. We taught robots to do give me 5-like interactions, which requires to recognize the human's action now, and also infer what kind of interaction type human want to do. Is it high 5, low 5, or no 10, whatsoever. And then robot is generating robot motion in the real time, established contacts, right time at the right hand, right body part of the humans. Besides of making contacts, also we can teach the robot some joint transport tasks. Here is done completely unsupervised manner from the zero knowledge at the beginning. So before learning about this joint transportation task, robots start with passive behavior, just following humans' force guidance. And as learning proceeds, robot becomes a more proactive contributor to the task by anticipating the path human want to go in the future, in the kind of 1 second in the future. And also we could make robot to collaborate on a furniture polishing tasks and so on, and make sure that robot is also dealing with unexpected force guidances using some variable impedance control and also varying autonomy levels of the robot in a shared autonomy concept. And also you can ensure the more passivities using more energy tank assumptions and so on, more formal approaches to make a safety part of it. So it is great to see that imitation learning concept can apply to cognitive and also physical human-robot interaction. Then our question is, then are we now really there? Are these existing approaches really sufficient to deploy robots in real world? And real world, like, let's say, serving cocktail parties. But probably most of us might say, not yet. And why? And why is so hard about it, right? We have still many challenges: unstructured environment, uncertainties, and safety, and sparse data, and so on. These are not the new challenges for us. We have been tackling those challenges for many decades, and we made some progresses. Here in particular, I want to focus on human side. Human makes the problem very special and also interesting. In my opinion, reading humans' intention is still largely uninvestigated. So let's look at the human intention estimate. In the past, human intention estimate has been formulated as like a human's activity detection and anticipation, kind of a classification problem. Or we try to predict continuous human skeletal motions, where human want to go, the kind of midterm goal positions, and so on. So we kind of regress the problems. But here in my team, now we try to look this problem a bit different perspective. So we want to look at now human in a situation. So namely, which object does human attend to? And with that object, what action human gonna act on it in the future? So we formulated now human intention estimation as detecting and anticipating human-object interaction. So basically, we try to find possible interaction between any human-object pairs in the scene. Through that, maybe we might be closer to understand intent of the human. So let me show you this graph here. So here, the human is approaching to the kitchen. At this time, ... robot is recognized, human is next to the laptop, and also it anticipates human gonna be in the future, 1 second later, next to the cup. Thus, robot is already start to preparing drinks for human, and so on. So here is the same thing with the videos. So human is approaching to the kitchen countertop here. Robot is recognizing, human is coming closer to the cup and drinks where robot is, and then he can serve the drinks. But then now human got a phone call and changed the mind and sitting on the sofa. And then now also human is start to opening up the laptop and work with the laptop. So robot recognize human doesn't need any more drinks. So I go back to the idle situation, idle positions. And then now it recognizes the human is again approaching to the kitchen. And then it's maybe human might want to drink again. So I prepare pouring activities for human. And it waits that it's fully sure about the human really wants that, and then human grasps the cup, and then robot is pouring drinks for the human. So far, in most robot demonstrations and so on, we saw that human always waits for the robot to react to the human, some kind of explicit gesture to do something. But here, with anticipation of the human intent, robot can initiate the assistive behaviors in advance so that we can realize more fluent human-robot interaction. So I discussed the human intention estimate with 3 different kind of formulation: anticipating activities and continuous motion forecasting, or HOIS, human-object interaction. Especially, I emphasize to consider humans in a contextual situation. To summarize my talk, I presented important challenges in human-centric robotics. So first, I argued that imitation learning from human is promising and also democratizing paradigm to realize the various tasks. And towards the embodied intelligence, we still need to tackle contact reach manipulation, which require high precision, force impedance control, and dexterity to handle tiny and flexible objects. And towards embodied social intelligence, establishing suitable, safe physical contact with humans and human intent reading is still largely open questions. So I discussed some of the challenges here. So what is the next? So influence of the large-scale models. In robot manipulations, foundations models are now actively leveraged due to the good generalization. And researchers attempt to learn generalist policies of a vision language action model. What about human-robot interaction? Maybe large-scale model might be still beneficial also for the human-robot interaction. And in fact, foundations models have been actively developed in the field of human motions and also human-human interaction generations. And our team is also exploring how to generate more interactive motions using human-human data and also combining with a motion retargeting algorithm from the human to the robot. So my last take-home message is that we still need to establish the fundamental mechanisms of intention. It should infer the goal of the human action and behavior, and using that desire of the human, and under current contextual situation, we can deduce the human's future actions. With that, robot can more assist to the humans more kind of active manner. And I believe that this fundamental mechanism of intention can become the crucial milestone towards to the human-centric robotics. Yeah. So thank you very much for your attention. And also I'd like to thank my team members and collaborators, and I'm open for any question.
Thank you. Any questions from the audience?
Hi, thank you for an interesting talk. In the video demo that you've presented with a bottle and a cup, what happens if there are more objects that can have more affordances and more combinations of actions that can happen between them? In those cases, I wonder where we are going to have a convergence of theory of mind and state affordances environments happening. I just wanted to get your insight on that.
Yes, so great question. We are still working on a lot of this theory of mind concepts here, but I think this intention reading can be one of the approaches. And there are obviously many possible assistants might be there depending on the objects there and so on. This is a very simple scenario as you can see. Now it is done by the kind of recognize what kind of intention or what kind of human object interaction is happening. Then we defined already behavior trees, like what kind of actions robot can take it as assistive behaviors. So I think it's gonna be a matter of time how to much really scale it up to that, right? So basically we have to see now, at this moment, robot can do that and that and that, assistance behaviors. And then we can learn about, in terms of that cases happens, then what we initiate the assistance of what. I think that is at the moment my answer. But I think this research area is really large and broad, and then we hope to get more research out of it. Yeah.
Sorry, may I have a follow-up? What's your take on how we increase the size of those behavior trees, right? Do we learn from natural human demonstrations? So both our ability to perform more assistive robotic actions and also our ability to scale the potential behavior tree of the human.
Yes, I think there are multiple ways of it. Probably we can also use a lot of LLM approaches, right, to get the possible, high-level task planning, high-level assistance. We can get a lot from that. I think there is a power into it as well. And then also we can be more in situation with that particular robot in particular scenarios, what kind of things we needed. And then I think if there is a service robot, then there are a set of the assistance we might need for that scenarios. And then we can get some demonstrations, and then we can learn about these behavior trees and task graphs, how to assist.
Thank you very much.
Yep. Hi there. Thank you for the interesting talk. I was wondering, so in human-robot interaction, the term intent is always very broadly and very vaguely defined. So my question to you as an expert, how would you, for your own research, define this term? What is an intention?
So for me, I think I just want you to point out, right? People are saying that, okay, I am doing intention recognition, right? But then you really look into the problem, it's very simplified there. And then I think what we are doing now is also still simplified. But only my whole take-home message is now, we try to look at the context there, and then tries to look at the objects around, and so on, this kind of context more explicitly out of it. And that is one thing. But then I think it's important to not know about this is kind of what really human has to goal about it, right? And based on that goal, we try to deduce what kind of action human gonna do in the future. Then we can also see that what kind of task planning human gonna do, what kind of action human gonna do, based on that intention ahead, then we can assist robots better. I do not have really great answer to that because this is also I think a research area. I want to work on it. I do not have it answered yet, but I hope to share the more information next time. Yeah.
Thank you.
Okay. So, sorry, we are out of time, so we have to move on to the next
But
speaker.
I will be there, so we can talk. Yeah.
Thank you.